Hello, this is Mr. Postiglione, Randall Postiglione. I'm doing this video. This is the second video for my new class. I am starting out the year at Holy Trinity for Ms. Raman, who is on maternity leave, and I'm with you guys until mid-September. Okay, mid-September. Okay, a couple of things. I want to talk about where we're going moving forward and what I saw last week. We were in class together 3 times, Wednesday, Thursday, Friday. By the way, this is August 23rd, 2020. We are going to be using whiteboards. I think this is going to help a lot. I want to hear I want to hear more from you guys. I want this to be more interactive. I know that's not real easy because some of you are, 10 miles away from me. But in any event, in class, I'm going to have whiteboards underneath your seats. All you need is a marker, a dry erase marker. If I have extras, I will give students extras so that they could take them home, and you can use these from home. I wish I had enough for all my e-learners. Some of you may have one of these. Okay, that's all you need is one. It's better than a piece of paper. This is for showing your answers. Okay, you can go like this, okay, and tell me what your answer is. Or you can just maybe get a clipboard and put a piece of paper, printer paper on there, and you can write your answers on there. Okay, no biggie, but I'm a little concerned that some of you at home are not really engaged, not really into it yet. You have to be. You have to be, otherwise you are not going to learn this stuff. You've got to be very attentive, and I will make sure you are. Okay, starting tomorrow, Monday, if you're at home, you have to unmute and tell me here when I call your name. Okay. All right. Let's talk a little bit about what I saw last week. I'm going to take my friend Albert down, and I want to move the camera closer. Okay, hope you all can see this. Last week, I think it was maybe the first day, I had you draw a ruler. Okay, draw a ruler. And 2 words came up, empirical and mathematical. Okay, and before I get into those, this is a ruler. It keeps on going, obviously. Here's 1 inch, 2 inch, 3 inches. This is a 1/2 inch. This is a 1/4 inch. This is an 1/8 inch. Okay, now I think I said, oh, well, maybe I've got a little ant here, and he travels maybe this far. Okay, from here to here. Told you to make little circles on there. Okay, some of you, when I asked, well, how far did the ant travel if he's on this ruler from here to here? Well, some of you just said, well, that's 1/2 inch, that's another 1/2, that's another 1/2, and then a 1/4 inch. So 1/2 is 1 when I add this 1/2 to it. So 1 1/2 inches, 1 3/4 inches. So some of you told me it was 1 3/4 inches that the ant moved. Okay? And you'd be right. That is empirical. You're using observation, using 1 or more of your 5 senses, which are sight in this case, hearing, smelling, feeling, Okay? All right. Now, there's another way mathematically. I know that this is at 1/2 inch, and this over here looks to be 2 1/4 inches. Okay, so what I can do is subtract 1/2 from 2 1/4. Because from 0 to 2 1/4, I know the distance would be 2 1/4. But I have to subtract this space right here, which is 1/2 inch. Okay, so I've got 2 1/4 minus 1/2. Okay, and that opened up a whole can of worms. Some of you forgot. I said, well, what are you going to do? How are you going to subtract this? Okay, some of you knew what an improper fraction was. 4 times 2 is 8, plus 1 is 9, 9/4 minus 1/2. Okay, so now we want to subtract 1/2 from this. I showed you a method. The method is, some call it today, the flying X method. It's something I came up when I was a sophomore in high school. I discovered this. Okay, I'm sure others did too, but that's when I discovered it. Here's all I did. I multiplied 4 times 2 to get 8, 9 times 2 to get 18. Now I'm subtracting here, I'm not adding. So 1 times 4 is 4. So I've got 14, right? 18 minus 4 is 14 over 8. And that is 1 6/8. And we know that 1 6/8 is 1 3/4. Simplifying that fraction, right? Divide top and bottom by 2. Okay, so the empirical way was just looking at this, which is very, very important in geometry. You'll be looking at a lot of angles and shapes, and this geometry class is going to change your whole life and how you look at things, look at your real world. But we have mathematics to prove things, just to be very precise, huh? We want to use the numbers. All right. So that was the first day. Okay, we talked about fractions, and one more time I just want to show you that flying X method. If I were adding these two numbers, and they are numbers, they're fractions. 7 times 9 is 63. Okay, 3 times 9 is 27. 2 times 7 is 14. Okay, it looks like 13 over 63, huh? Okay, it's ugly, but it's right. Okay, next. Okay, the next day we were talking about equations. I asked you, what was at the heart of algebra, and some of you said equation. Now, if I had a triangle that had 3 angles inside, one was x, another was 2x, and the third one was 3x, I don't know. I happen to know, and most of you knew this, that when you add up all the angles inside a triangle, no matter if they were 40 degrees or x degrees, we use x in algebra when we don't know the number. Not yet. Okay? But this is pretty cool. We know that they add up to 180, and I said just add these. Add the x's. Okay? Now this is an equation. It's got a left side, a right side, and equal signs in between. If I add these, I get 6 x's. Right? There's an invisible 1 over here. I divide by 6. Nothing cancels. That's 1. I've got x equals 30. 30 in this case degrees. So this would be a 30, 60, 90 degree triangle. okay, which is a very important triangle. You'll hear about that probably from Ms. Rahman when she gets back. Okay, but then we talked about formula. Now, this is a pretty special example here. Okay, I've got a triangle, a particular triangle, whose smallest angle I don't know, but I know the other two angles are twice and 3 times as large. Okay, that's pretty specific. But I mean, if I wanted to say, angle A plus angle B plus angle C in a triangle must equal 180 degrees. Well, that's more of a formula, huh? It's broader. Okay, it's not as specific. And we talked about rectangles. This is a rectangle. Maybe, I don't know, I think I said 30.5 by 7, something like that. Okay, I asked you to find out what the perimeter was. Some of you didn't know what perimeter was. Sometimes you get mixed up. P equals 2 times the length, because these are the same, plus 2 times the width, and these are the same. Okay? They're congruent. We learned that word congruent. Some of you already knew it. Congruent means same size and shape. Okay, this is a formula, okay? This formula is very broad. It's talking about, all the perimeters of rectangles. This little subscript there, okay? And here we just, substituted these numbers in here for width and length. Now, I showed you something pretty cool. If I had to multiply these, some of you know right away that it's 61, right? But if you say you didn't know that, you could break this up into 30 plus 1/2. Okay, this is 14. Okay, so now we use the distributive property. Remember that one? 2 times 30 is 60, and 2 times 1/2 is 1, or 1/2 of 2 is 1, plus 14. And the rest is pretty easy. 75. Okay, so that would be the perimeter, okay, of this rectangle. Okay, then let's see. We talked about area too. Area would be 7 times this. And some of you were in the woods there. You forgot how to multiply this. This would be 61 over 2. Right? You multiply the numerators and the denominators. This would be 427 over 1 times 2 is 2. So this would be 21, 2, 1, 3.5. And that's another thing. Many of you, maybe all of you, didn't know what short division was. I said, okay, if you wanted to divide, and this is a division problem, right, because it's a fraction. If you want a long divide, it'd be 2 into 4 goes 2. 2 times 2 is 4. You subtract, that's 0. Bring down to 2. 2 into 2 goes 1 time. 1 times 2 is 2. Subtract these, you get 0. Bring down to 7. This is 3, right? 3 times 2 is 6. There's 1 left over. So we put the 1 over the 2. Okay? Get the same answer. Okay? Now, I wanted you to try this. 4, 2, 7, and divide that by 2. 2 into 4 goes 2 times. There's nothing left over. Okay? 2, but if there were, okay, you'd put it next to the 2 here. I'll show you in a second. 2 into 2 goes 1 time. 2 into 7 goes 3 times. Okay, and then you carry that. All right. But what if it were 527? 2 into 527. Okay, this is a made-up example. 2 into 5 goes 2 times. But there's 1 left over. I put it next to the next number. 2 into 12 goes 6 times. 2 into 7 again is 3. There's 1 left over. I put it over the 2. Okay? You can short divide as long as the divisor is 1 digit. Okay? So, that was kind of a 10-minute review of what we talked about these last 3 days. I gave you a pre-test. Some of you did a really good job on it. Others haven't even attempted it yet. Some of the problems on there are pretty hard. They're pretty challenging. Try them anyway, though. But we really need to know just about everything on that pre-test before we're geometry ready. And that's the name of the game here. We want to be geometry ready, and that's what I'm here for the next few weeks, okay? Don't get me wrong, we'll get into the basics of geometry real soon, but I've just got to make sure that you've got a handle on the algebra that you need, the tools that you need to solve the geometry problems, okay? All right, if you're watching this on Sunday, I'll see you tomorrow, Monday.